I'm Pragya. Welcome to my channel where we talk about physics and learn a lot of new things. Today, we're going to learn about a topic which is not so fancy but very important to discuss: oil spills. And it probably happens more often than most of us realize.
Volcanic eruption a few days ago in Tonga was a catastrophic event. The underwater eruption was hundreds of times more powerful than the atomic bomb dropped on Hiroshima during World War II. It produced huge shock waves in the environment and created tsunami waves as far as in New Zealand, Fiji, and Japan. There was no contact with the island for many days. That noise, what went underreported, was an oil spill off the Peruvian coast triggered by the tsunami. Almost 12,000 barrels of oil leaked into the sea on 15th January 2022, as claimed by Peruvian Environment Minister Ruben Ramirez. Oil spills are so dangerous to our marine and coastal environment. The oil spill in Deepwater Horizon, Louisiana, on 20th April 2010 spilled around 760 million liters of crude oil in the ocean. In fact, according to some reports, 25% of that oil is still unaccounted for. Why is that so? Because you see, oil spilling in the ocean is quite unlike oil spilled in a puddle on a road. Obviously, puddles aren't deep, but oceans are. Unfortunately, we do not yet have a very good model incorporating vertical physics in oil spills, which basically means the oil carried by vertical currents during rough sea, or oil mixed with sand or sediment and thus sunken, is lost forever. But where does it go? Corals in Mauritius, which are one of the world's finest coral reefs, are under threat by a recent oil spill in July 2020. Because corals are made up of calcium carbonate, microscopic algae, which need this calcium carbonate, live inside the coral reef, and a symbiotic relationship between algae and coral gets established. It's this algae which gives coral its beautiful color. Oil spills essentially expel the algae from the coral, hence causing the death of the coral. And since a lot of crabs, mollusks, crustaceans live on the coral, the entire deep water marine ecosystem gets upset if the coral is bleached. The solution? It's obvious. Clean up. And clean up as soon as possible and as much oil as possible. And cleaning up as soon as possible is also important because once the oil bakes off in the sun, it turns into this starry gunk, which now resents even dispersant action.
Now, what are dispersants, you might ask? Dispersants are essentially detergent like chemicals, and adding these dispersants is the main way in which we deal with these oil spills.
You see, oil is hydrophobic, which means it hates water. When mixed with water, it floats on the top, forming a thin layer called sheen. So what we do first is to add a boom. Basically, it's like a giant floating pool noodle with a skirt to catch the oil. And then we either use like a skimmer to collect the oil. These skimmers contain oleophilic material. Oleo meaning oil and philic meaning loving. So oleophilic materials suck up the oil. The oil is then squeezed out. Or you can use a suction pump. Basically somewhat like a household vacuum cleaner. For the rest of the oil, mostly we add dispersant, which then breaks the sheen down into smaller droplets that they then mix more readily with water. Now you will notice that dispersants are doing nothing to reduce the amount of oil entering the marine ecosystem. It just prevents it from reaching coastline habitats. But in exchange, it pushes the oil underwater, thus endangering an entirely different set of marine ecosystems. In fact, a Canadian study from 2015 also confirms this, that these methods of cleaning oil can be more harmful than the oil itself. There are ongoing attempts to develop better oil cleaning methods. Researchers at the EMPA Materials Testing Lab in Switzerland have developed a sponge made of nanocellulose which can absorb oil up to 50 times its own weight. Argonne National Laboratory researchers have developed a new technology that recovers oil from water. They call it the oleosponge. The oleosponge is made from polyamide treated at high temperatures, and that ends up absorbing 90 times its own weight in oil. As a plus, it's also reusable. Another new breakthrough in this field has been claimed by Arden Warner, who is an accelerator physicist at Fermilab. So what he did was he added magnetite dust on a thin oil sheen and then applied magnetic force to attract the magnetite dust, which would drag the oil along with it. Interestingly, crude oil has just enough viscosity to lend itself very well to this process. Now, Warner claims it can even pull up oil from deep water, from bird feathers, from coastal marshes. He suggests a magnetic boom to collect the oil, and he also proposes a pulsating magnetic field inside the boom. The setup looks somewhat like this. The magnetic field, which is pulsating inside the boom, will pull the oil to the collecting stations. Like so. And the oil can then be separated in the ramp and then can be reused.
So if you didn't know, now you know. If you like this video, please give it a like, uh, share it with your friends, and please subscribe. I'll see you next time. Bye bye.